My goal was to evolve rock climbing behavior in a symmetrical two-armed robot. This is my list of milestones. As you can see, my project was only able to make headway into the first couple of these, leaving room for future expansion. I was able to build the robot body and evolve it to reach for a handhold on a flat surface, far from scaling a vertical wall, but challenging in its own right. My first step was to rebuild the robot's body. I scrapped the body from the main project and restarted with a body that consists of a rectangular torso along with three segment arms meant to more or less mimic the proportions and range of motion of human arms. Originally, I included a mini body in the shoulder to allow for movement through two dimensions, but eventually got rid of these when they caused issues and were unnecessary given the scope of my final project. I also restructured the neural network. My input layer consists of two touch sensors in the hands and six magic sensors, three for each hand. The magic sensors took as input the distance from the hand to the next handhold, as well as angles from hand to handhold in the XZ plane and the XY plane. Each of these sensors connects to six motors, two each for shoulders, elbows, and wrists. The most conceptually challenging part of this project was restructuring the fitness function, which saw many iterations. First, I simply evolved from minimizing the distance from left hand to handhold taken at the last time step. This often resulted in random flailing that just happened to score a good fitness. Next, fitness also took into account total movement of the left hand and tried to minimize that, which resulted in a robot too scared to move its hand forward all the way. Finally, the fitness function that successfully reached the hold was minimizing the sum of distances from hand to hold across all time steps. This got the bot to reach out quickly and keep its hand on the hold. Here's an example of the unevolved robot. Its torso is locked in place, and it really doesn't seem to be trying to reach for the hold at all, just kind of moving around. Here is the evolved robot. As you can see, its hand now makes a beeline for the hold, and it keeps it there over time. This chart shows the fitness curve of 1,000 generations of the robot as it tries to minimize the sum of distances over time. I think there were two big challenges in this project. The first was the trade-off between fast experimentation and understanding what's happening. Blind trials were great, but sometimes it took a while to catch on when something was going wrong or to figure out what needed to be changed because I wasn't always seeing the robot's behavior. The other challenge was trying to figure out what was fundamentally required to achieve the desired behavior. It took a lot of trials and dead ends to get a fitness function that worked, even as simple as it turned out to be. Definitely the big takeaway from this project is to get explicit when thinking about what you want your bot to evolve to do. Also, to just keep trying things. Tweaking things and failing repeatedly is part of the process. Given another semester, I would definitely continue to increase the complexity of the behavior, getting the right hand to reach for a hold, getting the bot to pull itself to the holds, and increasing the slope of the climbing surface.